For this video, we're going to do a shorter one so that we can talk about capacitance, myelin, and how that relates to our RI, RM, and finally our wavelength. So first let's talk about what exactly is capacitance. So capacitance is the amount of separation of charge per volt of energy. That makes no sense, so let's draw a picture. I always feel like I'm blocking the camera. Okay. That's really ugly, but you get what I mean. So that's a neuron. Okay, it's going to be our soma body. And then we're going to draw the axon, which is just like the long part. Then you're going to have like the terminal axon. That's ugly too. Terminal axon, okay? Some myelin. Ooh. This is my myelin. My myelin is made by my oligodendrocytes. Okay, so my myelin is made by my oligodendrocytes, and it's going to kind of surround my axon. Okay, so we have down here our voltage gated sodium channel. Alrighty, so we have our voltage gated sodium. We have our potassium, so our potassium is leaving. Okay, potassium is leaving, making it more positive outside here, right? We talked about this, which is going to make it more negative inside here. But when we have myelin, it's going to not be so close. It's not going to take as much, right? Because this positive charge is kind of saying like, no, we don't actually want you there. Right, but the negative charges, or the gradient of it, of high to low, is saying, yeah, we do want you out there, right? So over here, you're not quite getting as much, whereas if it's spread out, then this channel, right, then the lake channel is like, oh, okay, I guess we'll take you potassium, like it's fine. Okay, so amount of charge separated per volt. Okay, right here, there is it's very condensed, right, if you can see that. It's very packed together in comparison to this one, okay? So all of these positive charges are also like, hey dude, I don't really like you that much, no offense. I want to push away from you. And same with the negative charges. They're like, why are we all together? We don't even like each other. Right? Typically you wouldn't have positives next to each other like that, or negatives next to each other like that, as far as the charge goes. But you do have them together because you have this positive and negative relationship, right? That's like where we talk about the push versus the pull. Right? This is a pull. It's saying, oh, okay, actually, I'll stay here even though I don't like my neighbors because I like the people downstairs. That's essentially what it's saying. So this right here has a lot of capacitance. Okay, it's bound together very closely. There's a lot, it's very condensed. Whereas over here, these positive charges are like, hey, I don't really have to see you that much. I've got lots of room, I like my space, they've got some land. Right, the negative charges, same thing. They're like, okay, I have some room to put out my electrical field. I don't know if that's the right word, but like I can kind of spread out my negativity or my positivity, right? And so this part right here is like a little bit weaker, right? It's not quite as strong because they're not very close together, but still it's like, okay, I still feel you, I'll keep you around, okay? But because it's much less condensed than this one, we see that there's a lower capacitance. Okay, so let's say that we have an action potential. So this swings open. What color do I want? We'll do the turquoise. Okay, our voltage gated swings open. You get that sodium come through. Get that positive charges. For something that's high capacitance, you're gonna have a boom of positive, but there's lots of negative charges, if you will, to kind of soak it up. It gets soaked up super fast. That's called your RI. So there's an increase in your RI right here, right? And because the wavelength is so short, there's a decrease in your lambda, which equals your wavelength, okay? Whereas over here, if you get a boing, right, there's not as many pairs of charges. It's not quite so condensed. So you're going to have a decrease in your RI, but an increase in your lambda, an increase in your wavelength. Right? It's like, oh, okay, I can go a lot further because there's nothing blocking me. Then you also have something called your resistance of the membrane, or your RM. RM is just kind of talking about like the thickness is what I like to think of it as. So there is quite a lot in between these two charges. Alright, there's a lot of space between them. So you're going to have an increase in your RM. Whereas over here, they're super close together. So you're going to have a decrease in your RM. Okay, and capacitance. Hang on, let me remember. Okay, wait. So your wavelength equals your RM over your RI. I think. I'm not really a math person. It's the concepts that I care about. But that makes sense, right? And so as you have a decrease in your... What's the color I used? Okay. So if you have a decrease in your RI, right, because of an increased RM, right, because there's more space in between, you're going to have your wavelength be a lot longer. So that's capacitance and wavelength and what the myelin does, right? The myelin spread out the charges. So this is kind of like a key that I use on answering problems because it helps. So myelin is going to decrease capacitance. It's going to increase your RM. It's going to decrease your RI. And it's going to increase your wavelength. So it's like low, high, right? And so that's what myelin's going to do. It's decreasing your capacitance because there's more space in between, right? It still has the voltage of negative 70 inside the cell, right? But there's a decreased condense. It's less condensed. The charges are able to spread out a lot more, which means that when you get this long signal sent out, right, this positive charges for your action potential, it can go a lot further because there's less negativity inside that's trying to capture it. So then that charge, that Wong, is going to continue until it can open and hit another channel, right, which will then allow sodium, and then you can have more, and then that is how you're going to get an action potential down your neuron.